Hello everyone and welcome to the video for the inverse trig functions. This is section 6.5 in our textbook. Our skill objectives for this video are: number 1, develop inverse trig functions; number 2, find values of inverse trig functions; and the third one is graphing inverse trig functions. This one will actually be covered more in class. I'll show you what the graphs of these functions look like. The conceptual objectives are: number 1, understand the different notations for the inverse trig functions; number 2, understand why the domain restrictions on trig functions are needed; and number 3, extend properties of inverse functions to develop the inverse trig identities as well. Now to start out with, let's recall some things about inverse functions, not just trig functions, but in inverse functions in general. And the main thing I want you to remember on this one is that in order for an inverse function to exist, the original function must be said to be one-to-one, and which meant that there's no change in direction, and it would pass that horizontal line test. And remember, the passing the horizontal line test means that a horizontal line will intersect the graph of the function at most one time. Well, clearly, you can see that that's not the case for the sine, cosine, and tangent functions. So what we do with this, we will go through mathematically. We will limit that domain in a way so that the graph is one-to-one. And what you see as you look at the three graphs I have for the sine, cosine, and tangent, is that you'll notice that a portion of the graph is in red. That portion of the graph is what is called the principal branch, and it is the portion of the graph, if we limit the domain to just that piece, then the graph of the sine, cosine, and tangent functions are one-to-one. So for the sine function, we are limiting that to go from negative pi over 2 to pi over 2. For the cosine function, we're going to limit that to 0 to pi. And for the tangent function, we're going to limit that to negative pi over 2 to pi over 2. Now notice with the sine, we did include the negative pi over 2 and pi over 2. With the tangent, we're not including those endpoints because the tangent is undefined at pi over 2 and negative pi over 2. But by now limiting our sine, cosine, and tangent functions to those domains, we now have a function which is one-to-one, and so we are now able to define the inverse trig functions. Also, what this does, though, is it also puts a limit on what are possible answers for that inverse trig function. The first inverse function we'll define is the inverse sine. And I know the inverse sine, one notation you'll see is sine to the negative 1 power, or arc sine. That's the other one. Both of those are read as the inverse sine. They both mean the same thing, and they are interchangeable. And so with that, you will see both. And I will use both. I tend to use arc sine a little bit more. I think our book goes back and forth between it. It uses both. It's just a matter of the arc sine notation tends to give be a little less chance for making a mistake. But the idea here is that the domain of an inverse sine is going to be from negative 1 to 1. The range is from negative pi over 2 to pi over 2. Which means that the answer to an inverse trig function must be an angle, in this case the inverse sine function, must be an angle within that range. So, when I look at this first problem, arc sine of 1/2, what we're asked to find there in this case is they want to know an angle from negative pi over 2 to pi over 2, whose sine is 1/2. Now you can, that is on the unit circle. If you think about it for a little bit, you might remember it, but it does come out to be pi over 6. Arc sine of 1. Arc sine of 1, the angle on the unit circle that from negative pi over 2 to pi over 2 that has a sine value of 1. Well, that's going to be one of our quadrant angles, and that's going to actually be at pi over 2. And the third one is the arc sine of square root 3 over 2. Square root 3 over 2, again, we're looking for an angle from negative pi over 2 to pi over 2 that has a sine value of square root 3 over 2. In this case, if you remember, this one would come out to be pi over 3. Now, let's go to number 4, arc sine of negative square root 2 over 2. Because when we look at this, these angles, these particular angles that we have here are really the right half of the unit circle. You have to go through and you look at this one, and people will often go through and say the arc sine of negative square root 2 over 2, if you're looking just at the right half, they will come out and say, oh, that's 7 pi over 4. There's a problem. 7 pi over 4 is not a solution to this one. And so what you have to do on this one, think about the rotation. At the x-axis, if you to rotate to that angle, it would actually be going clockwise pi over 4 units, so it comes out to be a negative pi over 4. And the arc sine of negative 1 is going to be a negative pi over 2. Now another thing you can do, and it works with the inverse sine function, it will also work with the inverse tangent function, is we do have an identity, if you will. It's very similar to, it's an even odd identity. The arc sine is an odd function, and so I know that the inverse sine of a negative x is equal to the negative inverse sine of the positive x. So one thing I can do is use this to help out. So I could say on number 4, I could say, oh, that's equal to the arc sine or negative arc sine of square root 2 over 2, which I know that one from the unit circle, arc sine of square root 2 over 2 would be pi over 4, but because it's a negative, it would end up being a negative pi over 4. So you can do that as well. Now, the other thing you have with this is that these are inverse functions. And so one of the properties we also had with inverse functions is that when I do a composition of a function with its inverse function, they do undo each other. Now, it is provided that the value that went into the inside function is part of the range of the outside function. Well, in this case here, when I do the sine of the arc sine that we have there, that will equal x. That will equal x as long as, well, and in this case, that's always going to be, because the range is going to come out, x is going to be a value from negative 1 to 1. So in this case, as long as x is going from negative 1 less than or equal to x less than or equal to 1. In this case down on the next one, that is equal to x provided that x is between negative pi over 2 to pi over 2. Let's look at a couple examples. In the first one that we have here, the sine of the inverse sine of 2/3. Well, that one will come out to be, because the number that's in the inverse sine is between negative 1 to 1, and the sine value has to be between negative 1 to 1, this is going to be 2/3. In this case, that will come out to be negative 1/5. If this number that was inside the inverse sine function was bigger than 1 or smaller than negative 1, then that would be undefined. You wouldn't be able to do it. Now in the next one, next two that we have, 3 and 4, 5 is a little bit different. We'll talk about that one. But in these next two, we look at these angles. Now pi over 5 is between negative pi over 2 to pi over 2. So in this case, that will equal pi over 5. The same thing is true for negative 2 pi over 9. Negative 2 pi over 9 is, it is between negative pi over 2 to pi over 2. And so that answer is negative 2 pi over 9. The difference, though, is in the fifth one, the arc sine of the sine of 3 pi over 4. Well, in this case, 3 pi over 4 does not fall in that range from negative pi over 2 to pi over 2, into the range of the inverse sine function. And so when I look at this problem, I know that the sine of 3 pi over 4 is square root 2 over 2. So that's going to be the arc sine of square root 2 over 2. And so now we're looking at an angle that is from between negative pi over 2 to pi over 2 that has a sine value of square root 2 over 2. And that answer comes out to be pi over 4. So in that instance, right down here, where this angle is not between negative pi over 2 to pi over 2, it's not in the range of that inverse trig function, it's going to be something different. As in these two cases that we saw in 3 and 4, the angles inside here were within the range of the inverse trig function, so that they would just undo each other, and I would just get the pi over 5 or negative 2 pi over 9. Now let's take a look at the inverse cosine. We'll define that inverse trig function. In this case, the inverse cosine, again, we have the two notations, cosine to the negative 1 or arc cosine, and they are both read as inverse cosine. Domain, like the inverse sine, is from negative 1 to 1, but notice the difference in the range. The range is from 0 to pi, which makes it kind of nice because the inverse cosine is always going to be an angle that goes from 0 to pi, or every answer to an inverse cosine function is on the top half of the unit circle. And so when I want to know the inverse sine of 1/2, I can just go on that one and say, oh, the inverse sine of 1/2, that is equal, or sorry, inverse cosine of 1/2, sorry, that is going to be that will end up being pi over 3. The inverse cosine of negative 1 is the angle from 0 to pi that has a cosine value of negative 1. Well, that happens to be at pi. And the inverse cosine of negative square root 2 over 2 comes out to be the angle that's in the top half of the unit circle that has a cosine value of negative square root 2 over 2 is going to be 3 pi over 4. Notice the difference in terms of what can come out of that inverse cosine function. That is very, very key on this. Okay. Also, inverse cosine is not an even function and it's not an odd function. So doing things with the negative sign in there is not something that I would advise you to do. I would just leave it alone, because that if you try to change that negative sign, it will give you a wrong answer. And what happens on this one for the inverse cosine? Same thing is true with this, that this is going to be, in the first one, that will equal x as long as x is from negative 1 to 1. And in the second one, it will equal x as long as x is an angle from 0 to pi. So you saw examples of how we dealt with the inverse relationships in the previous problem with the inverse sine. What I'd like you to do right now is pause the video, and I would like you to identify the cosine of the inverse cosine of 1/3, the inverse cosine of the cosine of 2 pi over 3, and the last one, the inverse cosine of the cosine of 11 pi over 6. So use the properties, use the process that we showed you in the ones for the examples we did for the inverse sine, and once you're done, restart the video and we'll go through these. Welcome back. In the first one, that inverse the cosine of the arc cosine of 1/3, again, like it with the inverse sine, when we had the inverse trig function on the inside and the trig function on the outside, the 1/3 is something that's from negative 1 to 1, so the answer on that is equal to 1/3. In the second one, the arc cosine of the cosine of 2 pi over 3, well, remember that this was equal to x as long as the angle that we have here was between 0 and pi, and 2 pi over 3 does satisfy that, so the answer here is 2 pi over 3. But now we get to the inverse cosine of the cosine of 11 pi over 6. 11 pi over 6 is not between 0 and pi. So this one is not just going to be, we're just not going to undo it and say 11 pi over 6. I know the cosine of 11 pi over 6. This is going to become the inverse cosine of cosine of 11 pi over 6, which is equal to square root 3 over 2. And so when I look for an angle between 0 and pi that has a cosine value of square root 3 over 2, the answer on that comes out to be pi over 6. So that would be our final answer. That's what you should have had for the answer on number 3. Now let's get to the third inverse trig function. And notice these are the three that do appear on your calculator. And we'll talk about how you deal with the other ones as well in a second. But we have the inverse tangent, and again the notation, tangent to -1 is the inverse tangent of x, or the arctan of x. Now one thing you have here is that the domain on an inverse tangent is anything from -infinity to infinity. The range will be, again, very similar to the inverse sine, going from -pi/2 to pi/2. In fact, like the inverse sine, I know that the arctan of a negative x is equal to negative arctan of x. The inverse tangent function is an odd function, so we can use that property to help ourselves out on these as you work on these. So, in the first problem, we want to know what's the inverse tangent of 1. And the inverse tangent was an angle from -pi/2 to pi/2 that has a tangent value of 1, and that comes out to be pi/4. Now, inverse tangent of square root 3. Inverse tangent of square root 3 is going to come out to be pi/3. And so, using this property, the fact that tangent is an odd function, I know the inverse tangent of negative square root 3 is going to be the opposite of the inverse tangent of square root 3. And so in this case, number 3, the answer is -pi/3. Now again, as you're working on these things, the inverse relationship that we have, this is equal to x, and again, provided that x is a real number. And in the last one, that's going to be true. That will equal x, provided that x is from -pi/2 to pi/2. So like the inverse sine and inverse cosine, you have to remember that when you do the composition of this, that when it's an inverse tangent of a tangent like that, the x, what is the value of x, has to be from -pi/2 to pi/2. If it's not, you're going to have to make that adjustment and identify the angle that is within this range that does have that same tangent value. Now let's look at the other inverse trig functions. We have the inverse secant, inverse cosecant, and inverse cotangent. Now, the inverse secant, notice the -1x notation, and then the arcsecant. And that is going to be equal to the inverse cosine of 1 over x. Notice the reciprocal nature that we've took. Now, in this case, for the secant values, the domain has to be basically all numbered. It's when the absolute value of x is greater than or equal to 1. So in other words, if I think of that as an interval, that means that the domain is going to go from -infinity to -1, and it's going to be union with 1 to infinity. So that would be the domain. Now for the range. Remember that the range on the when we limited the domain for the cosine function, we went from 0 to pi. Well, the cosine function is 0 at pi/2, which falls within that domain restriction. And so therefore, when I look at the with the inverse the secant, that is undefined there. So in that case, our range, the possible values that can come out of an inverse secant function, are just going to be the values from 0 to pi/2, union with pi/2 to pi. So you're not going to get a value. There's no angle that has the secant of pi/2 does not exist, so that's not a possible value for the inverse secant. Inverse cosecant, or arc cosecant, and that again is the inverse sine of 1 over x. And again, like the inverse secant, the domain is going to be when the absolute value of x is greater than or equal to 1, or using interval notation, it's that same intervals that we had up there. And the range here is going to be from -pi/2 to 0, union 0 to pi over 2. And the last one we have is the inverse cotangent. And our cotangent, or the inverse tangent of 1 over x. That's the way that you can go through and use it on your calculator. And the domain there is going to be from negative infinity to infinity, and the range is going to be from 0 to pi. So I'll always get an answer from 0 to pi. Now the other thing you have to keep in mind on this one, these, especially with the inverse cotangent, it is not one-to-one. It's, all the inverse sine, inverse tangent, inverse cosecant do have that odd function relationship that you could use to help yourself out. That is not the case for the inverse cotangent. It is not an odd function, and it's not an even function either. So again, because your values that you can get out are always going to be positive values from 0 to pi. So this concludes the video that I have for the inverse trig functions. I know there should be a lot of questions there. We'll do some more examples, and we will look at the graphs of these. If you want to see, get a start on the graphs of those, if you look on page 651 of your textbook, you'll see a summary of all the information that we just did for the 6 inverse trig functions. So with that, I know you're also working on your quiz, so good luck with that, and we'll see you in our next class.